All right, today we're going to talk about inverse relationships and dealing with those functions. So I thought one thing, I know some of you study photography, so this is one idea that I had talking about those inverses, is up top we have this color photo and it's negative, right? So this is like when you took a picture with an old school camera that had film in it. This is what the film actually develops, right? And then you go through the process using the light in the dark room and all that stuff. So a certain percentage of chemicals. So there's a lot of math involved. And notice what happens, right? See down here, I'm trying to circle it, but you can't see it because I'm using the wrong color. Okay, where the letter B is, this is really, really light on the negative, right? Check it. Check it over here. That's the darkest spot there. Right? Underneath, I found this. This is super cool. This is a black and white. So notice the sky looks really dark and ominous, but it's actually because it's the lightest part in picture C. So these are inverses. Right? Pretty cool, right? Now we're going to deal with it in a mathematical version, so it won't look as cool, but know that it is. All right, one other thing that I had here, I did one of these when I was in like the 5th grade, right? It's called etching. It's called etching. So you start, this whole thing is actually covered in like black ink, and then you just start scratching away at it. And the more you scratch at it, you make that area lightest. So that means the artist here, to make this vertical column, right? They actually had to scratch all the ink away from it. And your brain has to work a little bit different when you're trying to do these. So if you want something to look dark, like the shadows going into this doorway, then you need to leave it alone. Okay, so if you get a chance in an art class in the future, try it out. It's pretty cool. All right, so that was the cool part. Now it's time for math, right? Yay. All right, so here's what we got. We got some ordered pairs. 0, -1. Okay, so this is A and then B for our ordered pair. We could say X and then Y, but I don't want to confuse you because it already says that. Now notice what happens. Everything that was in A is now B, and everything that was B is now in A. So we just flip-flopped them, right? Ready? Whoop, whoop. There they go. That's it. Okay, so if I give you a table, you're like, sweet, this is super easy. I can do this. All you can do is flip-flop. All right, so that's one thing I'm going to ask you to do here at the end. So don't forget that. That means we have an inverse. Now, this paragraph here, it gets a little technical, but all it is we're saying that if you have an inverse relation, that doesn't mean that it's a function. So identifying a function is still based on what we've done before, where we can't have any of the x's repeat unless it repeats the y value as well, right? Remember, it's like buying a hot dog over at Sheetz. Your hot dog cost $1, buying a hot dog costs $1.50. That's a problem. It's a problem. Okay, it's not functioning. The register is not functioning for that. All right, so here's what we got. So we have the original function. All right, this is good. This is yes, right? Because each one of these domain, 1.2, 1.4, 1.6, 1.9, okay, they have one arrow coming out of it. That's a good thing. Notice when we do the inverse, this is a big no-no, right? I can't have any of those domain values with 2 arrows coming out of it. So a lot of review mixed in here. So if you're not up on that, just brush up on your function definition just a little bit so we can answer some questions later on. All right, so what's this function actually about? What are we supposed to do to find the inverse? So here's the inverse. All right, so our textbook, being a high school book, it's going to use 2 steps. Step number 1 is to switch or change x and y. That's it. Step number 2 is to solve or isolate y. That's it. All right, so this equation starts off y equals x squared minus 1. Step number 1, x equals y squared minus 1. Boom, done. Step number 1. I'm 50% done according to the steps. It's going to take a little bit longer though. All right, what are we going to do? We're going to get y by itself. X plus 1 equals y squared. How do you get rid of the square? How do we get rid of the square? How do we get rid of the square? Boom, square root. So y equals, I'm going to bring it over here on the right, the square root of x plus 1. Boom. All right, did they ask me about function yet? No, not yet. All right, I won't bother you with it until it comes up. All right. So we change x and y, we solve for y. Done. What's the inverse of this one? I don't know, man. I'm a little bit scared. There seems to be a lot more going on. What's it say? What's it say? What's it say? What's it say? All right. So change x and y. X equals, you sure about this? Y minus 4 squared plus 5. I'm still scared. I'm still scared of this problem. No, I'm not. I'm just messing with you. Subtract 5. There it goes. X minus 5 equals Y minus 4. This thing is locked together, right? And you guys that really hate foiling, you're going to love inverse functions because we don't want to do that. So now what we're going to do is bring in my old friend, the square root. All right, notice that's going to cover the x minus 5. So I have to make sure that whenever that happens, I write it that way. So I need the square root of x minus 5 equals y minus 4. I know what you're thinking. Hey, Mr. Tool, why'd you leave that big gap in there? Because I'm not about to write all this stuff over and over and over, because I know you don't want to either. So leave a little gap in here. For what? What am I leaving it for? Boom. Because I need to add 4 to this. Okay, so there it is. These cancel, and we got it. Wait, do you really think these are inverses? Or am I just making stuff up? Well, let's prove it real quick, like 0, 1. That's all I want to do, right? 0 and 1. That's all I'm going to do. Okay, so let's plug in 0 to this original equation. All right, so 0 is going in here. So I got 0. What's negative 4 squared? That's 16. What's 16 plus 5? 21. Man, that was not as easy as I thought it was going to be. What if I plug in 1? Okay, let's plug 1 in here. 1 minus 4, that's negative 3 squared is 9 plus 5, that's 14. Man, why are you using these messed up numbers? I don't know. All right, if they're inverses, that means 21 better give me 0 and 14 better give me 1. All right, let's plug it in. 21's going in. 21 minus 5. We can take the square root of that. Square root of 16 is 4 plus 4. Okay. All right, we're going to use the negative on that. So we're in good shape. 0, let's plug in 14. 14 minus 5 is 9. Square root of 9 is 3 plus 4. So we use negative 3 plus 4 gives me 1. We're in really good shape here. We're in really good shape. All right. Okay, so we can prove it using that AB and BA over here. That's kind of how we talk about it in a real basic way. And eventually we're going to talk about how we solve it in Algebra 2 way. All right, finding the inverse of a function. Here we go. I know what's happening. Your eye's going straight down to B, right? This thing here, this f to the negative first power, all that means is inverse. That's saying, hey, can you find the inverse? That's all it means. It's a notation thing. All right, what's the domain and range of this? So for this, I got to remember, what does the square root of x look like? All right, square root of x looks like this. All right, so what's the square root of x minus 2 look like? All right, let's see. So x minus 2, that's inside, so it's going to move it left and right, and it's opposite. So I'm actually going to go to the right 2. Okay, so this is the one we're working with. So the domain, x starts where? Starts at 2. It's going to the right. So that's greater than or equal to the range. Y, is this going up or down? Yeah, it's going up. It's starting at 0, right? Because this ordered pair right in the beginning is 2 comma 0. So that makes that a whole lot easier for domain and then range. All right, let's find the inverse. Okay, remember f of x, same thing as y. So I'm going to start by writing it just the way it was. I can get my pen here. Y equals the square root of x minus 2. Okay, find the inverse. X equals the square root of y minus 2. All right, this whole thing's covered. So the first thing I have to do is actually square it. So I have x squared equals y minus 2, and we're going to add the 2. I forgot to leave my space. Y equals x squared plus 2. Easy peasy, right? Now, if I asked for the domain and range of that, you should be all over that as well. Okay, so domain, we're talking about a parabola. So that's going to be all real numbers. The range, this parabola happens to be moved up to. So y is greater than or equal to 2 to get that last part. Okay, so like I said, this, since we're dealing with these functions, is going to put a lot of old stuff together. Function definition, domains, ranges, all this stuff coming together. It's like a big old snowman. All right, so we showed you AB and BA, and you can make a table just to prove it. But what we really do in Algebra 2 is a composition of functions. This is what we've been dealing with for the last couple days. And all it means is if I take the function and I put it inside the inverse, the answer has to be x. Okay, I know that sounds weird. That means the only thing that should be left is x. Now if I take the inverse and I put it into the function, I also have to get just x. And this has to work for both. Okay, so this is where we're going to be careful and really work like some Algebra 2 students to show that you know what's going on. Okay, so what I'm going to do is find the inverse. Remember, this is, let's just get rid of this. This is y. All right, x equals 1 over y minus 1. All right, first things first, I got a fraction. I'm not freaking out about it because I just made it into a proportion by setting it equal to 0. Not equal to 0. I put it over 1. I'm crazy this morning. I don't know. All right, so here's what we got. I got x times y minus 1 equals 1 times 1 is 1, right? This is the result, cross multiplying. Boom, boom. Now, again, I don't want to put these into each other. I'm trying to solve for y. Don't forget that. Divide by x. So y minus 1 equals 1 over x. And I'm going to add the 1 so I can be done with this thing. Okay, so this is what we have. All right, we want to prove that they're inverses, but we're going to do it the Algebra 2 way. Okay, so this is going to look like substitution from way back in working with systems of equations. Okay, so I'm going to take this inverse, okay, and I put it right here, which is in place of this little x. Now this result has to be x and only x. Otherwise, I didn't really find the inverse. All right, so all those parentheses down here, those were just to prove that we did a substitution. Okay, so let's get rid of them. So what's positive 1 minus 1? That's gone. So what's 1 over x? Yeah, that's 1 divided by 1 over x, which is actually 1 times x over 1, right? Look at that. The first half we did prove. Now, it's pretty rare, but sometimes you can prove one and get the other one to prove that it's not. So we're going to work both ways. So now what I have to do is I'm going to take the original function and I'm going to put it over top of, okay, so over top of, or underneath 1, so it goes right in here. So now I'm proving by putting the original function into the inverse. Now we just proved this first term to simply just use the reciprocal. So I need x minus 1 plus 1. Okay, so this whole thing just turned into x minus 1, right? Because I'm dividing by a fraction, so I want to multiply by its reciprocal, so we're going to get x minus 1. After that, I have negative 1 plus 1, so I get just x. Okay, we have proved without using a table that these are inverses. All right, good stuff. That's what it's all about. All right, so we may have a sequence of questions that look like this. And what they're asking us to do is, remember, this is find the inverse. So x equals 4 over y plus 2. When this happens, put x over 1, cross multiply, but don't actually multiply, right? Because that would make things a lot worse. Because then, you know, it's like doing the hokey pokey. You got to put the x in, then you got to take the x out. Yeah, it's a mess. All right, so we're trying to solve for y, so I'm going to divide out the x. So I got y plus 2 equals 4 over x. And now we're going to subtract the 2. I'm going to use a little scribble here to get rid of it. All right, so this is our inverse. Now we go through this sequence, right, where it's saying, okay, well, now that you found the inverse, I want you to use what you have been doing. So plug 0 into the inverse. Well, that's a problem. 4 over 0 minus 2. Well, this is undefined, So there's no solution. Well, that wasn't very helpful. Let's see what the other one does. Okay, so now I want to put 0 into the original. Okay, so I got 4 over 0 plus 2, right, because that was our original. So that's 4 over 2, which is 2. And now they're saying, okay, put that into the inverse. So here we go, 4 over 2 minus 2. Okay, so now we're using the spot way over here. So 4 divided by 2 is 2. 2 minus 2 is 0. All right, so that works. Okay, we can get 0, so, but it is there's a chance of getting a no solution as we deal with some of these fractions, and that's perfectly okay. All right. So 2 quick review questions to deal with just these tables. Remember, this is AB, this is BA. So 0, 0, 1, 1, 4, 2, 9, 3. Look at that. Okay, you just found the inverse of a table. Is it a function? All right, number 11, 2, negative 3, 2, negative 2, 2, negative 1, 2, 0. Same question. So we know this is now x and this is y, right, at AB and then BA. Real quick there, we just had to flip-flop them. Is number 11 a function? All right, next item we have deals with finding the inverse of some of these functions. Okay, so we're just going to pick 2 of these real quick. Number 13, I like 13. 13 can be a lucky number. So let's find the inverse. All right, hopefully you got that right. Otherwise, we should have x equals 2y minus 1. We're going to add 1, so it's x plus 1 equals 2y, and then divide by 2. So that's what we're looking for. X plus 1 over 2. Is the inverse a function? And that's a whole separate question. So that means you want this to look like 1/2 x plus 1/2. So is that a function? All right, let's make sure we deal with one of these squares as well. And it looks like 15 would be fun for that. X equals 5 minus 2y squared. So notice I'm just going to flip-flop those, and now we're going to subtract out the 5. Let's divide that negative 2 out. Notice the order that everything's happening. The square root is going to be the very last thing. So as I look at it this way, I want to make sure everything gets covered by the square root. All right, so knowing what you know about square roots and what the graph looks like. So here's the parent. This one's going to do some movements. Is it a function?